Okay, so today we want to talk about Pythagorean theorem. You've used Pythagorean theorem before. I think you are aware of what Pythagorean theorem is. We want to be able to use it to help us find a distance between two locations as well. So we're going to talk about how to apply Pythagorean theorem to finding a distance. And if you're into memorizing formulas, there is a distance formula that you could memorize when you're finding the distance between 2 points. Sometimes that formula is given to you on certain tests, whether it be maybe the NISA test or something like that. They might give you the formula, but who wants to memorize more formulas? You don't need to, because you can just figure it out by doing Pythagorean theorem. So that's what we want to deal with today. So what is that? Hey, John, can you shut that door? Is that the video in the science room? I get a muffled. Okay. So Pythagorean theorem, what is it? Do you know it? What'd you say? Somebody say triangle. It deals with a triangle. What triangle do you use? A right triangle. And Pythagorean theorem would have to be used with a right triangle. So we have a right triangle. And what does it say? If I had side lengths of A, B, and C, what's Pythagorean theorem? Yes. Yes. You multiply A by itself, you multiply B by itself, add it, and see if it equals C times itself. A square, correct. So you probably know it as A squared plus B squared equals C squared. That's Pythagorean theorem. A squared plus B squared equals C squared. Well, what does that mean? What they are telling you is if you have a right triangle, a famous right triangle that we have is known as a 3, 4, 5 triangle. Dimensions of 3, 4, and 5. Side lengths of 3, 4, and 5. So if I were to take a right triangle and look at the side lengths of 3, 4, and 5. Oh, let's back up. When you talk about a triangle, in a right triangle, if you have a right triangle, we have special names we call the sides. In the right triangle, the two sides that make your right angle are known as the legs. And what's this long distance right there? The hypotenuse. And what's the longest side of a right triangle? The hypotenuse. The hypotenuse will always be the longest length. Okay, so we go back to our 3, 4, 5 triangle, and what they are saying when you're working with Pythagorean theorem is it says that if I were to create a square, so if I were to create a square off of one side, it would have dimensions of 3 by 3. What is the area of that square? 9. That's the area of it. That's 3 times 3, which is what Pythagorean theorem is saying. So if I come up here and saying 3 squared, which has that area of 9. And then if I were to take the other leg and create a square off of that side, keep in mind, I should have slid my, that doesn't look like a square, does it? Yeah, it's close enough. If I make that a square, which is 4 by 4, what's the area of that? 16 plus 4 squared, which is 16. That should equal, now I'm going to go into my figure here, or my work. If I create a square off of that side, which has lengths of 5 by 5, what's the area of that? 25. So what they're saying is if I were to add the right angle, makes your plus sign, so you know what two sides to add together, the squares of those sides. If I were to take 9 and add 16 to it, I should get 25. And you do. You'd have to rearrange them just a little bit. I can't put those two squares right next to each other. I'd put my 9 over here, and that doesn't look like a square. But if you rearrange the little squares that would be in there, you would get that value. A squared plus b squared equals c squared. You've worked with Pythagorean theorem. I know you have. Okay, so let's look at an example. Maybe. Let's look at an example. If I were to look at this figure, I don't think I have these grouped together, so let me group them. Okay, they're grouped together. What if I ask you to find A? How would I set up Pythagorean theorem? You're to that point. Would you do it? How many of you sit here? I heard a different answer, and that's the way I would work through it. But a squared plus b squared equals c squared. Well, a is a. What's b? 4. And c is 7. And if I think about it, right here's my plus sign, so I got to take the 4 and the a, and that's what I'm going to be adding together. They're the two legs. A squared plus, what's 4 squared? 16 equals 7 squared, or 49. How do you solve that? Subtract 16 from both sides. Very good. So I get a squared is equal to 33. How do you get rid of a square? Square root. So a is equal to the square root of 33. That's your answer. Now I sit there and I say, a has to be what as far as length? It's going to be greater than 5 because the square root of 33 is in between. If I look at where the square root of 33 is, that's between the square root of 36, which is 6, and the square root of 25, which is 5. So 33 is between 5 and 6, closer to which value? 6. It's closer to 6 because 33 is closer to 36 than to 25. Does that make sense that that's what that would have a length of? I know A has to be less than 7 because your hypotenuse is always the longest side. So it's got to be less than 7. And your answer is the square root of 33 is less than 7. Now, in this process, when I first asked you how would you solve it, right away Isaiah said something different. He didn't give me this right here. What did he say? Well, I know that 7 is your longest side. So I'm going to have to subtract one of the other sides from it to find the other leg. So right away, Isaiah went into this. 7 squared, then what did you tell me? Minus 4 squared. Would you say equals a squared, or would you say, okay, so that equals a squared. But then what do you have to do to that? How do you get rid of the square? Square root. So you might eventually get into the point where you say, oh, the hypotenuse, I know that, so I subtract the square of the other known side, and then as a final step, I have to take the square root. So 7 squared is 49, minus 4 squared, which is 16, and you take the square root. Look over here off to the side. Isn't that what we were doing right here? 49 minus 16, and then what did I do to it? I took the square root. So he's just grouping all of that into one process instead of going through and always setting up a squared plus b squared equals c squared. I don't care what you do. In the future math classes, you will probably see me getting to that point right there. But if you have to go through all of these steps right here, feel free to go through all of the steps. A squared plus b squared equals c squared. Now we say it's used for a right triangle, but You can actually use Pythagorean theorem, and you will encounter this next year, but I can tell you right now because you can use it. I have no doubt you guys could work through a problem like this right now. You might see something like this on maybe your NISA test or something. Special right triangle is going to be 3, 4, 5. That's always true. 3 squared plus 4 squared will always equal 5 squared. And you're going to run into some others that you will work with. 5, 12, 13 is another special right triangle. But my question for you is, what happens when the square, remember when I drew the square over here? What happened when the area of that plus the area of this is larger than, what if the sum, so what happens if a squared plus b squared is greater than c squared? What does that mean about the square that comes off of that hypotenuse? Smaller, right? This has to be smaller. So in order for the square to be smaller and have a smaller value, this hypotenuse cannot be as long, correct? So in order to create a triangle, in order to take this leg right here and create a triangle, I'm going to have to move this in that way, right? And that blue piece, the blue that I have is that shortened hypotenuse, may have to angle up just a little bit more. And I'm going to slide this red leg over. What type of a triangle is created? An acute triangle. You can actually use Pythagorean theorem, it's called an inequality, to help you determine if you have a right. If it's right, it's going to be equal to c squared. You can use it to figure out if you have an obtuse or an acute triangle. If the sum of the two legs is greater, your hypotenuse has got to be shorter. And in order to create that triangle, I have to drop this in. And when you drop it in, you get an acute triangle. Think about it over here. Let me do another one. So what happens if a squared plus b squared is less than c squared? So I have this square here, and I add to it this square over here. What happens if this square off of the hypotenuse is larger? If it's larger, then I got to make it bigger, right? So your hypotenuse, let me put it in green, your hypotenuse has got to be longer. So what do you have to do to this leg right here to create your triangle? You're going to drop it out this direction, but then what do you have to do to the green? You're going to slide it down, drop it down, and what type of a triangle is created? Obtuse. Now, that's easily seen when we start, you could use these to help you visualize that, what's going to happen. Like right there, there's a right triangle. What happens if the hypotenuse is shorter? What happens if this was shorter? I would have to bring this side in, and what type of a triangle is created? Acute. Because the sum of this red and yellow, the sum of the red and the yellow legs, the squares that come off of there, are bigger than that square. They're bigger than that square. So in order to get that triangle, you got to slide it in. You get your acute triangle. Let's see if this works. All right, there's where they're equal, right? The purple and the yellow equal the blue. If I talk about the square, what happens if the hypotenuse is greater? You have to create your triangle, right? So the purple and the yellow is less than the red, so to create my triangle, what type of a triangle do you get? Obtuse. See what we're trying to do up on the board with that? That's one thing you will encounter next year, but it's something you can use when you're using Pythagorean theorem. Now, the next thing with Pythagorean theorem is that you could be asked this question. Use the Pythagorean theorem to find the distance between the points 4, 2 and negative 3, 4. Well, let's graph. Let's graph those points and see what they mean by Pythagorean theorem. So I plot the points. Where is 4, 2? From the origin, where am I going to go? To the right 4 and up 2. There's your coordinate point 4, 2. Where's the coordinate point negative 3, 4? I go from the origin and I go left 3, up 4. There's your coordinate point negative 3, 4. They want to know what is that distance between those 2 points. And they're telling me to use Pythagorean theorem. How can I use Pythagorean theorem? I can make a right triangle. I can drop this down and move this across. How far over what is the length of that bottom leg? Well, I go 1, 2, 3, 4, 5, 6, 7. The length of that is 7. What's the height of the other leg? 2. So how am I going to find this distance, x, which is that length between the 2 points? I am going to, here's your plus sign because there's your right angle right there, right? So it's going to be 2 squared plus 7 squared equals x squared. Or what do you have to do? Take the square root of 4 plus 49. Now I did multiple steps right there. Are we okay with that? I squared them and got rid of this square over here by doing the square root. What's 49 plus 4? 53. Your length of that hypotenuse is square root of 53. About what? Well, it's between the square root of 7, which is 49. So the square root of 49 and the square root of 64. It's between there. So it's a little great. It's greater than 7, right? But less than 8. Does that make sense? Yes. I know that x has to be greater than 7 because it's the hypotenuse, and the hypotenuse is the longest side. Now, they can get you into a distance formula. That's what some things are going to try to confuse you with. And they're going to say, what's the distance between 2 points? And they're going to say, oh, well, to find the distance between 2 points, you have to know a formula. Why learn another formula? That formula you got to learn says that it's going to be x1 minus x2 squared plus y1 minus y2 squared. Another formula? And I have to memorize that? What do you think the x1, y1, x2, y2, what do you think those are? It's the x values in your points and the y values in your points. Here's your first x value. Here's your second x value. Here's your first y value. And here's the y value of your second point. Use the formula. The square root of, what's the first x value? 4 minus the second x value, which is, did I do that right? Negative 3, 4, and 4, 2. X value, yes I did. Sorry, just threw me off there for a second. I don't know what I was thinking. Sorry, right there. And then what's your first y value? 2 minus the second y value, which is 4. Okay, here's what you do. If you can see that, what is 4 minus negative 3? 7, and you square it. Plus, what is 2 minus 4? Negative 2 squared. What is 7 squared? 49. What is negative 2 squared? Negative 2 times negative 2 is positive 4. And when you solve, you get the square root of 53. Same answer, but you got this formula there. You just want to know what is this distance on the x-axis. We counted because we plotted the points. That's the same thing as just subtracting the two numbers. You go 4 one way and you go 3 the other. That's a total length of 7. You start at 2, you go up to 4. That's a total length of 2. That's what they're finding here. Does the order in which you subtract them make a difference? No, it does not. I could have used -3 minus 4. That's going to give you -7. And you would have to square that, which gets you back to that 49. So the order of that does not make a difference. I want to give you another example. Can you use, and I'll give you time to work through this, Pythagorean Theorem to find A? So I'm going to give you lengths of 5, 9, and A. All right, I'll give you a minute. Go ahead and work through it. How many of you directly went to, oops, sorry. How many of you directly went to 9 squared minus 5 squared, and then you take the square root? Anybody go right there? 9 squared is 81 minus 25, and you take the square root, which is going to give you the square root of 56. Good. If not, you can still go back and say it's a squared plus 5 squared equals 9 squared. Go ahead and solve. All right, one last example. I want you to find the distance between the following 2 points. The coordinate point 5, 3, and the other coordinate point is going to be -2, -3. I will give you a minute. Go. Can I do this without pulling up graph paper? Is that okay? If I were to graph these points, I have the coordinate point 5, 3. So I'm going to go over to the right 5 and up 3, right? Then you have the coordinate point -2, 3, so I'm going to go back 2 and down 3. I need to know, what's this distance right there? Well, how high up did I go right there? I went 5, 3, and then I went down 3, so that total length there is 6. I also need to know how far over I went. Well, from the y-axis, I went this direction, how far? 5, and I went back how far? 2, so that total distance there is 7. So I have a right triangle where I have 6 and 7 for the 2 legs. Right here is your right angle, which means plus. So it's going to be 7 squared plus 6 squared. And then what do you have to do as a final step? Take the square root. So you get 49 plus 36. And if you add those together, you should get the square root of 85. Now, if you accidentally subtracted them, you get a value of the square root of 13. That's between the square root of 9 and the square root of 16, which is between 3 and 4. Does it make sense that this side right here would be shorter than 6 or 7? No. It's got to be longer than that. The square root of 85 is between the square root of 81 and the square root of 100, so it is between 9 and 10, closer to 9. It makes sense that x is a value of 9. It's the longer side. Question?